Hello everyone, welcome to day 8. So yesterday I completed this question. We'll move to the next question. Left rotate array by k places. This is same what we did yesterday. This is already done. I'll mark it as done. Next is move zeros to the end. Given an integer array, move all the zeros to the end of it while maintaining the relative order of the non-zero element. Note that you must do this in place without making the copy of an array. Okay, so we are given this array. If we are allowed to use extra space, then we can create one more array and start iterating over this array. We'll create the second array of the same size, and once we start iterating, whenever we find an element which is non-zero, we'll put it in the new array. So it will be 1, 3 and 12, and rest of the elements will mark it as 0, and this will be the result. But in the question we are asked to do it in place. So for that, what we can do is we can take 2 pointers in this array. If this is the array, we'll take 2 pointers. One we will use to iterate over this array and find the non-zero element, and the second pointer which will keep track of the zeros. So let's say initially the first and second, both the pointers will be at start. We'll check if it is 0 or non-zero. If it is so I'll write it down. First pointer will be at 0 index and second will also be at 0 index. Now we'll check if it is 0 or non-zero. It is 0, so we will move the second pointer but not the first pointer. So second pointer will be at 1, index 1. Now again we'll check if it is 0 or non-zero. It is non-zero. So we will move the first pointer. So we will swap these two. What we will do is we will swap the second and first. Swap the second and first elements. First and second elements. Okay. And then we will iterate. So iterate both of them. So first will become 1 and second will become 2. Okay. Now what we are doing, we will again check. First has become 1 and second has become 2. Again check if it is 0 or non-zero. It is non-zero. It is 0, so we will just iterate second will become 3. Now again it is 0, so we will swap first and second. We'll again do the swap, and now the array will become like this: 1, 3, 0, 0 and 12. And now we will iterate. First will be 2 and second will be 4. Again the second is non-zero, so we will swap the first and second, and the resultant array will be this of 3, 12, 0 and 0. I think this should be fine, so I'll write it down. We'll take 2 pointers. First equals to 0 and second is also 0, and n is nums dot size, nums dot length. If n is 1, then return. If the size of there is only one element, then we don't need to do anything. Now for int I equals to 0, I is less than n, I plus plus, we will check if this is second, which we are iterating, not I. Now we will check if nums second is 0, then we will simply do second plus plus and move ahead. We'll not do anything, so continue. Second plus plus will happen automatically. Else if it is non-zero, then then we will swap nums second and nums first, and we'll do first plus plus. So we can write it in this way as non-zero, then we'll do this, otherwise do nothing. Java swap to array elements. There should be a built-in method for that. Collections dot swap works on list. Okay. Okay, so we'll have to use temp only. I'll write a swap method. Or let's do this. So int temp equals to nums second equals to nums first, and nums first equals to temp. Let me try one more case. So if this is 23 and we have 0 and 0 before also, okay, and what if there are zeros at the end? Okay, let's submit it. This worked. I'll quickly see one of the solutions. So okay, so they are making the last element, and this also is fine. I'll mark it as done. Then the next question is linear search. Given an array and an element num, the task is to find if num is present in the given array or not. If present, print the index of element or print -1. So the easiest way, I think, should be that we iterate over this array and find the element and print the index. What is this about? Is there some trick? The same thing, right? We'll iterate and check time complexity is why this question is there in this. Okay. Union of two sorted arrays. Given two sorted arrays, array 1 and array 2 of size n and m, find the union of two sorted arrays. The union of two can be defined as the common and distinct elements in two arrays. Okay, so this is first array and this is second. Union will be common and distinct elements. So which elements are is common in union? Okay, so all the elements but uniquely which are present in both of them, and these two are sorted. Okay. So one way of doing this would be using set in Java, because set always contains unique elements. So we will iterate over this array and put all the elements in the set, and again iterate over this array and put all the elements, and then the set will contain only the unique elements, and then we'll print all the elements of that set. This is one way of doing this. But it will require extra space, so I think that is what they have done here. Using a set distance that holds any duplicate, hence does not hold an initialize a set. I'll check the code. So we are using a set tree set. We'll add all the elements in the set and then return the set as array list. This is one way. Other way of doing this would be once what will be the complexity of this? So time complexity will be m plus n log m. Inserting element in set takes log n time, where n is number of elements at max set. Okay, fine. In two pointer approach, we will take 2 pointers at the start of the array, and we will check if both the elements are same, then we will print one of them, and one second, let me think. So I'll try to write the code here. So these are two arrays. We'll take 2 pointers and both will be at the start of the array, and we will start iterating. Now we will check if both are different. So we will print the smaller one, because they have said that it is a sorted array. So we will print the smaller one and iterate. Now we have 2 and 2, right? What if this was also 1? So what will happen? So we will iterate here, and again 1 and 2 smaller one, so we are not supposed to print that. So we will check. Okay, fine. So if let's say we have this, both of them are different, so we will print the smaller one and we will iterate. We will print or store the smaller one and we will iterate, and this is currently 1 is printed. And we will iterate only the smaller one, where we found the smaller one in that array. Now we will compare both. If both are equal, then we will print any one of them. So we will print 2 and iterate both. We are at 3 and 3 again, and at each step we will check. Once we are going to print, we will check if we have already, the current is already that value. If it's already there, then we will not print that. So 3 and 3, again we'll print 3. Then we are at 4 4, again we'll print 4. Then we are 5 4. So a smaller one is 4, but we have already printed 4, so we will not print. We'll iterate, and we are at 5 5, so we will print 5, and that's how it will work. I think that's this is pretty straightforward. I'll just check the code. they are doing the same thing. Okay, so I'll close this. Find missing number. Oh, this question is present on Geeks for Geeks. Okay. Given an array of size n minus 1 with distinct integers in range 1 to n, this array represents a permutation of the integers from 1 to n with one element missing. Find the missing element. 1 2 3 4 5 6 is missing. Okay, like that. Okay. One way of doing this would be we will use a map, and we'll check if all of one way easiest way of doing this would be we can sort this array and then iterate from the start and see which element is missing. That is one way of doing this. Okay, the other way of doing this would be we'll use a map and store the count of each element, and then we'll iterate over the map and check which element is missing. Third way of doing this would be what if we know that there is a formula to find the sum of first n integers 1 to n, right? So we'll find the sum of 1 to n, and we will find the sum of this and then subtract both of them, and the missing the difference between these two, the sum of this and sum of 1 to n, the difference between these two would be the number which is missing. I think that's the best solution for this. Let's see. Hashing, so they are doing the searching, linear search for missing element. Then they are doing the hashing. Okay, then they are doing the sum approach. So sum is this, and we'll subtract both of them. Then there is one more approach, XOR operation. It is taking order of n time. XOR of number with itself is 0, that is XOR x is 0, and a given array has, this means that the result of XOR of first n natural numbers with XOR of all elements. Okay, fine. Next is missing consecutive ones. The lead code option is there. I'll do it on lead code. Given a binary array nums, return the maximum number of consecutive ones in the array. So in this, max consecutive number of ones are 3. In this, it's 2. Okay. So what we can do in this is, okay, I'll close it for today. We'll do this question tomorrow.